Welcome to Matrickz Tech Talk. In this podcast show, we bring in the industry leaders and experts in the automotive domain to share their experiences along their journey. The mission of our podcast is to start a dialogue that will allow us to understand the development of automotive industry and where the automotive industry is going. You can ask questions to our guests directly. Just send us an email to podcast@matrickz.de. We'll schedule a call with you during the recording and you'll be part of our show. Today we have a CEO from an award-winning company, Celexica, Maximilian Odendahl. Max, welcome to Matrickz.
Thanks a lot for having me.
I'll tell you a little bit about Max. Max is the CEO and the co-founder of Celexica, which is a company formed in 2014 and became a world leader of software development automation. Based in Germany, they're present in the United States and in Japan. So Max personally is a computer engineer who studied at RWTH Aachen University and graduated in 2010. He worked as a chief engineer at RWTH Aachen, the chair called Software for System on Silicon, with 15 other researchers. So Max, at Celexica, let's start with the vision. Where do you want to go in the next 5-10 years, your company, and what is the vision there? What is the problem that you're trying to solve for?
Yeah. So the future is going to be very smart. We all know that, right? If that's autonomous vehicles, if that's robots walking down the street, if that's the drones following you while running or doing firefighting, it's going to be very smart, intelligent applications, right? In order to make that work, you need a lot of compute resources, right? You need very, very powerful hardware, which is being built. But the problem we're seeing is, developers cannot keep up with this amazing hardware. It's just too complicated, right? So how do you write software in the future for those very powerful, hardware, multi-core hardware, heterogeneous computing, all similar stuff? So we believe, there needs to be like a fundamental change in how we develop software. We need help, basically, right? And this is what we're trying to do. How can I bring software onto hardware, right? Not with an Excel sheet, not with relying on the senior expert who did it manually the last 30 years, based on existing know-how. No, but based on technology. Which actually understands your software, can help you, can guidance you into how to utilize your hardware, right? So very similar, what happened electronic design automation 30 years ago. People were drawing their hardware with, by pen, more or less, drawing lines. Well, at one point it just got too complex, so the electronic design automation industry started. We're trying something very similar. Software design automation, so to speak. There's no way you're going to, figure out how, one application has 10 million lines of code. I'm going to integrate that on some heterogeneous supercomputer with 20 other applications, and it's just going to magically work because you designed it to work in your Excel sheet. That's not going to happen, right? So I think, we need help.
This is what I was talking to my team when we were talking about product development. Look at a problem that you solve today and try to make yourself unemployed, because that's what's going to happen anyway in the future. If you don't do it to yourself, someone else will do it. We have been doing manually now. First of all, if you automate that, you're already creating value, and the complexity will force you to automate. So that's a fantastic vision.
And I think I would have to disagree with you. It's not about getting rid of the developers. I think there's no way you can do this. There's always going to be smart people involved. It's more about making sure he can actually get his job done with the help of automation, right? Because the complexity is exploding, right? Both on the hardware side as well as, especially how to create software for that complex hardware. There's just no way in how, he can do his job at all. Mm-hmm. So it's, making sure he survives and not trying to get rid of him.
Absolutely. This is also what I mean by making yourself unemployed. Doesn't mean that you will be unemployed in a literal sense. It's just that your job will be different. It is different. Yeah. You used to write C code. Now you have a button click to generate C code from a model. Yeah. So what we have been doing, software engineers, we're we're making ourselves unemployed in a sense that we have a different kind of job, which is we're more productive. We don't have to spend that much time. Our jobs get easier and we're more productive.
And one way to solve complexity is by raising the abstraction, right? So you mentioned you go from assembler and then C and then parallel C++. You add all those different, adaptive AUTOSAR is going to come. I guess we're going to talk about automotive later, which is yet another abstraction layer. But that doesn't mean you get closer to hardware, because that's the opposite of it. Well, I still need optimized implementation, right? It still needs to be maintainable and efficient and needs to be maintained for the next 30 years. So on the one side you want abstraction, but you still need to squeeze out performance. That doesn't match, right? So I think that's where you need tools to help you.
That's where you need tools. So tell us a little bit about the products Silexica is offering right now in the market, and what can you do with it? How many products do you have?
So we have like 8 products right now. They all have basically 3 steps in common. The first one is, the analysis phase, I call it. We actually understand what we're looking at, and that in an automated fashion, right? So I would look at your code or your binary, and I understand what's in there, right? So automatic, compiler-based analysis. We do static analysis, just looking at the code. We do dynamic analysis, so I actually execute the code and look at the behavior. And we're also doing semantic analysis. So I would not just see, there's a memory access, but I also understand what that memory access is actually doing, right? Is that a semaphore? Is it a lock? Those kind of things. So I think very unique combination of different analysis kinds. To really get a holistic understanding of, what is this code doing, building a model automatically, representing your software, basically, right? And then the next step is, once I have a model, now I can do a lot of cool things with it, right? I can optimize it, I can extract parallelism, I can tell you how it will behave on different systems. So, let's say design space exploration, I can come up with automatic, mapping and scheduling decisions. And then the third step, I can give you guidance, I can update an AUTOSAR configuration, I can get the code ready for an FPGA, which means I have to insert some high-level synthesis pragmas, right? Depends on the flow, but I not just want to give you insights, but I also want to tell you what to do as a next step, right? So to make it a little bit more concrete, one example, we have a product for AUTOSAR Classic, right? Where we can automatically analyze an AUTOSAR-based software. We can, tell you what to put where, right? Calculate automatically a scheduling, and then output an optimized AUTOSAR XML, which would go into the, downstream tooling from Electrobit, from Vector, and so on, right?
If I understood it right, you analyze the code. This is the first step. Then you optimize, meaning that you find out the possibilities of parallelization or probably memory utilization, things like that. And in the third step, you tell the developer what to do. Do you also automatically generate parallel code or things like that?
So in the AUTOSAR world, we don't generate updated code. What we do is we generate updated AUTOSAR configuration files, right? Which includes where to put your global variables automatically into which memory section, right? Which includes, what task, what runnables do you want to put on which core? In AUTOSAR, the beauty is it's somewhat parallel already, right? It could be run on a single core, but you still have task-based programming. So yes, we can also split up, a runnable into several runnables. But I think it's more on a, let's say, system level, what to put where to put your buffers, those kind of things. It's not about, magically changing the code. And often you don't even want that, right? You don't want code generation because it might be certified already and you just want to change the scheduling order, stuff like that, right? So it's more about updating the configurations and then somebody else, takes that configuration and generates code again.
You optimize in terms of performance, or do you also optimize and your guidance, or are they solely performance related, or are they safety related, security related? In which direction are these guidance?
Good question, because there are two things, right? One is what's the optimization criteria, and I'll answer your question in a second. The other one is what existing constraints do you have, and they could be in different areas, right? So we build a very large framework where you can have different constraints, but also different optimization criteria, right? So one optimization criteria could be make it as fast as you can, right? Well, usually it's not about make it as fast as you can. It's more about, well, I need to meet my constraints, right? So maybe meet the constraints with the smallest hardware there is, right? So optimization criteria could be performance. It could be peak power, right, which is important as an example for base station design. It could be average power or heat, which is more important for automotive, ADAS, autonomous driving, right? Because you're worried about the heat of the chip. It could be safety. It could be how much memory are you utilizing? How big is your stack? I mean, there's a whole bunch of different criteria. The other one is the pre-mapping, right? You have an FFT. And you have an FFT, in software, and you have an FFT accelerator. It's pretty clear you want to map that FFT to the FFT accelerator. I don't need a tool to figure that out. So that could be an example of a pre-mapping constraint, right? It could be make it as fast as or make it as power efficient as possible, but I have an existing latency or throughput constraint, right? So constraints and optimization criteria need to go hand in hand.
So if we think about the classic automotive V model, your tool will be, if I understood it right, be a part of the tool chain where the actual configuration will be generating code, and hence this code will be in the car. So this is absolutely in the V chain, V model, in the tool chain, right?
Yeah, and I think the vision here is for several parts, right? Yeah. Because you can use our tooling. I mean, one part is this automatic analysis, but you can also use it for scheduling design before you have even written a single line of code, right? So at the early design phase, you can use it for validation or optimization, right? Once there is code, okay, how do I distribute that now? And there's also the validation phase, where you can check, okay, what I designed in the beginning, does that actually still match, right? And you want to do that continuously, right? If you think a step further, not thinking on a single application, but multiple applications, is it going to work in the future that everybody does their own V cycle and at the end of the project they throw it together and just magically works? In AUTOSAR Classic environment, it somewhat works because everything is static and you can design it that way. Think about that, you have 10 different C++ applications, multi-threaded. Everybody works on their own V cycle, delivers according to the spec, throws it together at the end. It's not going to work, in my opinion, right?
Absolutely.
So I think there needs to be a continuous V cycle, even cross-product, right? Or cross-software components. Where I think it needs to be a continuous V cycle, and you need tooling to do that, right? Where some integration work is not just done at the end of the project, but in a continuous fashion.
Yes, the iterative V model. Yeah. Automotive industry is about to face the biggest disruption in the last 50 years. Driverless car.
Yep.
So what's your thought on that, and how your product will have impact, or even your company be benefited from this shift?
To enable that, it's all about the central supercomputer, right, in the car. Yeah. So you don't have a lot of ECUs talking to each other, but you're going to have a very, very powerful, very complicated platform, centralized platform, which is not just going to be more cores, but it's crazy amount of heterogeneity, right? You're going to have Intel or ARM processors doing high performance computing. You're going to have an FPGA for sensor fusion. You're going to have neural network accelerators. You're going to have a GPU. It's going to be everything in one big platform. And we're back to how to integrate different software, how to optimize for such a scenario, how to understand the whole interactions between those different clusters, right? There's no way to plan that or debug that or profile that, right? So what are you going to do if it doesn't work, right? To which team do you send that back? Was that a bus contention problem? Was it a scheduling problem? Should you have added more parallelism or less parallelism, right? Nobody has an answer to that, and that's really where our tooling is going to help with this kind of system analysis, not just optimize one individual application for a given platform, but understand the interaction between different applications on a given hardware, right? And to me, that's key element to not have a prototype with the trunk being completely full with 200 Intel machines, but actually making it work in production in a centralized embedded supercomputer, right?
Matrickz vision is to bring safety and security together in autonomous mode. In order to make things safe and secured, you have to have the bigger picture. So will your tool also help in safety or security analysis?
It's certainly going in that direction. And one very trivial example, let's have two multi-threaded C++ application. Could be ROS2, could be adaptive AutoSAR, and they run on the same chip, right? Well, it's going to be some kind of dynamic behavior, right? Because most likely you're not want this static planning of everything like in the old world, AutoSAR classic world, right? No, but there's going to be a scheduler. It could be Linux or whatever, ROS2 scheduler. So there's going to be dynamic behavior. How do you understand corner cases? How do you make sure you really tested everything, right? It's not about, hey, I profile for 2 weeks and nothing happened, so I think I'm done and I'm going to ship it. No, you basically have to prove or make sure that all the different permutations which are possible are not leading to any kind of issue, right?
Right.
There's no tooling out there whatsoever. You cannot drive around 5 billion miles and say, yes, I've met this case. So I think with this new dynamic types of application, with the new interaction between a lot of different clusters, I think there's going to be a lot of challenges to prove that you're ready to ship this and put it in production.
You mentioned there that they basically do 3 things and 8 products. Can you tell us what are the 8 categories?
So the 3 steps I mentioned before, that you can find that in each one. Why is it more? Why is it not just one product? Why is it several products? We believe you need to, or not just we believe, everybody believes it needs to be integrated into your existing workflows as much as possible. So if your input is AutoSAR Classic, that's a very different flow than you're doing adaptive AutoSAR type development, right? It's also very different flow than if you want to target not an Matrickz 2G, but you want to target your code for an FPGA where you have to do a lot of different things, right? The 3 steps are still the same, but the way you prepare code, the type of parallelism, all those kind of analysis are very different. So the technology core, I think, is the same. The different steps are the same, but the kind of integration, the kind of input and output you would give, they are different, right? Optimized for AutoSAR Classic, optimized for adaptive AutoSAR, optimized for your targeting and FPGA, and that's why it's different toolings, right?
Okay, it's platform that makes it categorized. Okay.
I think more the environment. Yes, target platform is one, but especially the input, right? Is that is that a neural network? Is that AutoSAR code? Is it you're just designing it and it's just a formal model, or is it C++ code? Those are going to be very different challenges you're going to face, and that's why it's different tooling, right? But the core is the same or similar.
So what technical challenges do you face when you go to a typical automotive project, to a typical automotive ECU where you deploy your tools?
I wouldn't say there's something specific. I mean, the general theme is everything is different, right? and everybody knows that who's in automotive, or I guess in any difficult technology environment. Everybody has their existing workflow, working style. Everybody's not working 100% according to the standard, but they add their little stuff around it. They have different existing tooling, different knowledge. So building a product which can really automate everything, or make sure we don't have to automate everything, but make sure it integrates quickly to show value, right? Because the key problem is nobody has time, right? There's a nice LinkedIn comic where a guy is pulling a wagon with 4 squared wheels. And then there's a guy coming and say, I have a round wheel, I can make your life easier. No, we're busy, right? And they keep pulling the wagon. And I think there's a lot of truth to that, right? If you don't show value quickly, they don't even have time to look into your stuff, right? Because everybody's so busy, deadlines are so tight, so much pressure to be the first and whatever. So I think there are technical challenges, but there's also, let's say, the environment just makes it hard to solve a problem quickly. Right?
If someone is interested in your product, they should definitely go to solexica.com.de. And is there any demo online? How to get in hands-on on your?
We have a resource section where case studies, white papers. We have a couple of videos. We also have hands-on videos explaining exactly what's the input, what are we doing, what is the output. So I think it's much easier to grasp what we're doing instead of listening to me. So yeah, there's a lot of material there. So I would encourage everybody to check out the website. And if there's interest, give me a call, send me an email. I'm happy to come by.
Thank you, Max. It was lovely having you.
Thank you for having me.
If you have liked our show, please feel free to write comments or write to us at podcast@matrix.de.